and welcome to our first digital lesson. Alright, so we have our notes. Again, if you don't have a printer to print out the notes that are provided for you, just grabbing a piece of paper and pausing the video a lot to write everything down that's on the screen so that you get all of the equations and the problems will work perfectly fine. Our first lesson is about using quadratic regressions in standard form and vertex form. Now, a regression is the type of line that we typed into Desmos for linear and for exponential functions and did the cool squiggly line thing to have Desmos show us the equation that goes through the lines. So I need you to highlight some things for me here. The thing I would like for you to highlight first is the quadratic regressions equation. That is the one you're going to be typing into Desmos. Now, the next thing I want you to highlight in potentially a different color is actually straight down at the beginning of each of these equations. What do you notice is at the beginning of every single one of the equations after either the squiggly or the equal sign? There's the letter A. So the letter A is the same in each of these. In standard form and in vertex form, the A is the same number. Vertex form has a B and a C because it's alphabetical order. Sorry, did I say vertex form? I meant standard form. And vertex form has an H and a K since that makes my vertex like we learned before the break. Now what's really nice about the fact that the A's are the same is that if I know the vertex, I know H and K, and if I can find the quadratic regression, I also know A. So we're on a mission today to find all of these letters to write different types of equations in both standard form and vertex form. But we're always going to begin with standard form in Desmos. So for example, you might get a question like this, and this is when math starts to get really cool because we're talking about projectile motion here. It says a projectile, which is like a ball is launched into the air from the ground. What goes up must come down. That's a quadratic. The graph shows the path of the projectile at different times. Write both the standard form quadratic and vertex form quadratic equation that can be used to model this situation. Okay? First thing we need to do is find some coordinate points. Well, we have a graph, so we can find 3 coordinate points because we can find its vertex and the zeros. We could also find one of the ones in here, but it won't be as detailed defined because we're going to be looking mostly at the points that we can find. We know that this is 0, 0, 3, 6, and 6, 0. So I can go ahead and fill in my table. 0, 0, 3, 6, and 6, 0. Those are the coordinates that are a part of that projectile, of that ball going up and down. Okay, now to write an equation, I'm going to click over to Desmos, and you are going to have to use Desmos for this lesson, and I'm going to add a table. Now I want this table that's on my paper to be on my Desmos. And that table was 0, 0, 3, 6, and 6, 0. It goes ahead and it plots the points for me, and I don't just want the coordinate points, I actually want the regression line that connects those points together. So I'm going to type the fancy version that you highlighted on your notes, the fancy version of the quadratic with the squiggly, which was y1 squiggly line, ax squared 1, that's important, plus bx1 plus c. Both the a and the b here get, the x's get the 1's next to them or else you're not doing it correctly. And the x for the first part is both squared and has a 1 underneath it. That's a lot. Let me say that again. y1 squiggly line, a x squared 1. Make sure there's both a squared and a subscript of 1 there, plus bx1 plus c. And once I've done that, I'm going to go ahead and get the a, b, and c value for this graph. I don't know about you, but I think that a value is kind of ugly. Negative 0.6666667 is a really pretty fraction. So since that's the letter a, we're going to let Desmos tell me what a is. It says, well, I told you a is negative 0.67. But if you click the little boxy box button, it's going to change that to the pretty fraction of negative 2/3. So now I know the a, the b, and the c. So I'm going to go ahead and write those down. I know you can't see me do this because I'm writing down here on my notes that A, that B, and that C value. Okay? This is going to be y equals negative 2/3 x squared, that's A, plus 4x plus 0. I'll hop back over here for a second. Okay? Those are the numbers I got out of Desmos. Negative 2/3 x squared plus 4x plus 0. A, B, and C. If you wanted to leave A as a decimal, that's fine, but this is a much prettier fraction. I would prefer the fractions. And now if we want vertex form, we just have to fill in vertex form. Because beyond needing just the vertex, which again is on my picture, I just needed that A value. It should be the exact same as the standard form. The vertex for this graph, if you look back up at the top, is 3, 6. So that means we're going to have x opposite of 3 squared plus 6. And voila! Using the h and the k from the picture, I can write the vertex form of this equation. Again, the a's should be the same in both equations because they're using the same letter. But the h and the k are coming from the vertex that you see in the graph. Okay? Vertex is coming from what you see in the graph. And remember, it's the opposite of the h. So the h was a positive 3, so I make sure minus 3 shows up in my equation. Okay? There are a lot of examples on these notes, and I'm not necessarily going to go over all of them in the video because you'll stop watching. But I'm going to go over a few of them that you need to see. Okay? There's a bunch of problems you can try. Miss Jackson's key will have all of the answer choices, or all the answers on here if you wanted to go ahead and do them and check your work. But since we're doing the distance learning, I'm not going to make you do all the problems. If you can right now, I would love for you to stop the video, and I would love for you to try number 3. Okay? We want to write the standard form and vertex form for this projectile that is being launched. Go ahead and stop the video and try it in your Desmos. Alright, hopefully you've had a chance to try it. Just number 3 right now. So we're going to come over here to our Desmos and we're going to type in that table. I'm going to get rid of everything right now. Okay, let's type in that table. It is negative 2, negative 1, 0, 1, and then negative 18, negative 35.5, negative 60, and negative 91.5. Okay. Now I want an equation. Well, I can't even see the points. I'm going to click the little magnifying glass so that it zooms out. There's my coordinates. See them? Okay. Did I type all this in correctly? I did. Alright, so this is going to be y1 squiggly line, ax squared, scoot over, 1, plus bx1 plus c. There's the curve that's going to go through all these points. Okay, it's given me now my vertex as well. I can see the vertex in this on Desmos. It wasn't a coordinate I was originally given, but Desmos shows me what the vertex is, which will come in handy later. Now, negative 3.5 is a nice looking fraction. If you wanted to, or nice looking decimal. If you wanted to use a fraction version of it, you just ask Desmos to tell you what a is as a fraction. But I'm going to go ahead and use negative 3.5. If you see negative 7/2 on the notes, that's because that's the same fraction. Okay? So we would come to back to our notes, and we will write down that standard form function. We'd have h of x equal to negative 3.5 x squared minus 28x minus 60. That's the a, the b, and the c that I got out of Desmos. Negative 3.5, negative 28, negative 60, the same numbers. And if I wanted to find vertex form, I just remember that when we looked at the graph, that it told me the vertex was at negative 4. What was it at? Hold on. Negative 4, negative 4. Okay, yeah. Negative 4, negative 4. That was the vertex that Desmos told me was created by that regression line. So when I use the same A negative 3.5, and then finish filling out vertex form using the opposite of h, comma k, from my vertex, I'm going to be done with vertex form. Okay, the a's are the same. The h and the k is your vertex, opposite of h and k. A, B, and C you get out of Desmos. Cool. If you want to practice this more, we will have more problems for you to practice after the video. There's 3 more here that you can do on your own and check your work with Miss Jackson's key. If you look down, oh, I can't scroll with that. I can scroll with this. We have another type of question you might see. You might see something that says, write a quadratic function in standard and vertex form that has the following vertex and goes through the following point. This time you're either given a verbal description or like not enough points, because we need 3 points for this to work in Desmos. How many coordinates are we going to need? 3. If you use 2, it's not enough. You have to have 3. But what we do know in being given the vertex and another point is we know that there exists a line in this problem that's invisible and cuts the parabola in half. Hopefully you remember that that is called the axis of symmetry. The axis of symmetry is exactly in the middle of this parabola. So we know every point that's on this side also has to show up on this side, the same distance away. If I'm here at this blue point and I want to find its opposite or its reflected point, I just have to figure out how many I have to jump to come in, 1, and jump that many out, 1. So there's actually a whole nother coordinate here. We not only have negative 1, 3, 0, 0, we also have 1, 3. That's the other coordinate that I'm going to be able to use in Desmos to create my regression line. So let's go ahead and do it. Get rid of these and start again. We have negative 1, 3. We have 0, 0. And we have 1, 3. I'm like super zoomed out. Let me zoom back in. That looks pretty good. We type in the equation. It's y1 squiggly line, ax squared, scoot over, 1 plus bx1. Don't forget that second one has to have a little bitty subscript of 1 next to it, plus c. And now it tells me all the info I need. It has 2 numbers that are 0, and that's okay. We can write this as either of the following for ABC. We can say that this is y equals 3x squared plus 0x plus 0, or we could just write this as y equals 3x. Or sorry, 3x squared. Both of those are the same. They represent the same thing. This one is one that we wrote down first is showing you the a or the b and the c that are 0. The other one is assuming you remember that those will disappear. Now, if we wanted vertex form for this to show every part of it, we know that the a is the same, so there's still going to be a 3 in the front. And that instead of numbers, I'm going to have zeros in there. And that's perfect. That is the vertex form that tells me where the vertex is and what the scalar factor is. We're going to do just one more of these, but I'm actually going to go do number 7. So if you want to try number 7 before I do it, that would be ideal. So we're going to come over here and do number 7. Again, 6, 8, and 9 will be done on Miss Jackson's notes, but I'm not going to make you watch me do it because you'll stop watching. Okay, this time it didn't give you a picture, it gave you a description. It said, well, the vertex is at 3, 5, and it passes through 6, 0. We have to do the work this time. So what I'm going to do is I'm going to plot my 3, 5 vertex over 3 up 1, 2, 3, 4, 5. There's my vertex. And my other point is at 6, 0. 1, 2, 3, 4, 5, 6, 0. Okay, I know that there is going to be an axis of symmetry through the vertex. So if I needed to find another point, I just have to count how many it takes to reflect that passes through point to the other side of the axis. It takes 1, 2, 3 jumps to get to the axis of symmetry. which means I need to jump 1, 2, 3 more times away from the axis of symmetry to find my other coordinate. The 3 coordinates I'm going to use for this particular graph are 0, 0, 3, 5, and 6, 0. Let's pop back over to Desmos to get our a, b, and c values for our standard form function. We have the table of 0, 0, 3, 5, and 6, 0. y1 squiggly line, ax squared 1 plus bx1 plus c. Ooh, it's going to give me an a and a b value that are both fractions. Let's go ahead and make those cuter, or give me decimals. Let's make them cuter fractions. So here's a and b, but I'm going to make them both fractions. Much better. You just wanted to round them to the nearest tenth or so, that's fine. But I'm going to use the fraction version because it's much prettier on these. Okay? -5/9 and 10/3. So if we come back and we write the standard form, y equals a, which was -5/9, x squared, plus b, which is 10/3, x plus c, which was 0. I could leave the 0 off, that's fine. And the vertex form, since I know the a value is going to be the same a value, -5/9, x minus h plus k. Remember again that I'm getting h and k from the vertex that it gave me. Opposite of h, so there's -3, and then k. The a's are the same, which is why we use Desmos to find out the scalar value. Let's pop down to number 10, which is a star type question, or how we would ask on might ask on multiple choice questions. It is the same kind of question as number 7, but when you're presented with multiple choice answers, you can do some matching to match up the vocabulary and not necessarily have to go through the entire regression sequence. What I mean by that is, we're going to take the information of having a vertex at -5, -1, and the passes through point of -2, 17, and we're just going to see which one of these answer choices does that. Okay, so let's go put that in there. We got to get rid of all of this stuff. Goodbye. We're going to type in our vertex, which was parentheses -5, -1. Just for good measure, because I'm showing you guys what we're doing, I'm going to say that this is the vertex. You don't have to label it. The other point was -2, 17. We want to see, it's off screen, we want to see which of our graphs that we get as an answer choice will go through those 2 points. Here's A, y equals -2, x plus 1 squared minus 5. Yeah, that parabola is like way down there. Do y'all see it? That doesn't even come close to going through my vertex and the point. So we are going to eliminate answer choice A. Big O cross through. It's, oh, not with a highlighter. It's not that one. Let's try B. Y equals -2, x plus 5, x minus 1. Okay, so that one has the right vertex, but it's totally facing the wrong direction. It's a negative parabola when we're obviously going to need a happy parabola. So it is definitely not B. Let's try C. This one just has a 2 in the front, and then a +5 and a -1. All right, let's see. Oh, snap. That has the correct vertex and goes through the point. Looks pretty good. We'll keep that one as a potential answer choice, but let's just eliminate D before we're totally done. That has a +2, and then a +1, and a -5. Okay, that one doesn't even have the right vertex, nor does it go through the point. So we know that it's definitely not D. In a multiple choice setting, you are going to be able to use Desmos to help match up the information that you know with the graphs. Okay, could have done regressions, could have reflected that line over the vertex like we did in number 5 and number 7. you will be asked to do that way. So if you need to go back and watch number 5 and number 7 again, that would be helpful. But in multiple choice, you have options. Okay, if there's anything today that I went over, since I didn't do that many examples that you are confused about, please message me and please come on my office hours so I can show you. I can share my screen so I can do the problems again for you if you need to see me explain it again a different way. We empower, we impact, we love. We are Skeeter Nation.